we'll do some of the exports and imports into Maestro real quick so you can practice with that. There are a couple different options when you go to export the beams. And here, let me show you this one. I'll export some of the deck beams right now. So if we run this script, and we just say polyline and direction, and that's typically what I use for the decks. So I'll grab all of the stiffeners. Okay, this is actually a good point here. As you saw earlier, I had all of these grouped, but if you start the script and then go to select the lines, you select them individually. It ignores whether or not they're members of a group. So if you want to take advantage of the fact that I've already grouped these things, you want to pre-select them. So if you have them selected ahead of time and then run the script, and I say polyline and direction. Now, if you're running polyline and direction, it doesn't care if that beam trace is on the mesh or if it's just out in 3D space somewhere. It's just taking a polyline in 3D space and you're specifying the direction, and it'll just write that out into a Maestro neutral file. And when you pull it into Maestro, you'll have a beam sitting out in space. And in Rhino, Z is the vertical direction, so I want to say -Z. It'll swap the X and Y values when it pulls it into Maestro, since Maestro has Y as the vertical and Z as transverse. And that's why I like to check the box for transform nodal coordinates. We'll say make these beams point down and go ahead and export. And so this would be in a Maestro neutral file. I'll say save. Similarly, I can select my frames. And again, these would be the deck frame. I would go just a polyline and direction, and it would be -Z and frames. Now, when you go to write out your shell stiffeners, this is where I would want to use the mesh normals. Now, if we turn on these beams, you can see it was built from the mesh. So the nodes defining the curves are at all the same locations as the nodes that define the mesh. If I were to modify one and not the other, then if I tried to compute the normal, when it got to this beam segment and it looks at the first point and it tries to find a point on the corresponding mesh, it won't if I've moved it. And that one segment would fail to write out. Now, if you had your beam traces first, you could use all of those nodes to create your mesh. That's fine. Or if you have the mesh first, you can use all of those nodes to create your beams, and that's fine too, as long as there's a correlation between them. So if we take these beams and run the script, and we say polyline on mesh, it will then ask us for a reference mesh. So we want to pick a mesh that has those beams, and I think I had all of the beams grouped in there. It won't hurt if we select too many meshes. This is just the meshes it's going to look into, so it's not a big deal if there are extras in there. Where that can be an issue is if you have and there's an example of this in the video, where if you're doing like longitudinal and transverse bulkheads and you have a beam that hits the corner, so it actually has a point that corresponds to two different reference meshes. If it happens to pick the wrong mesh as its reference, you may wind up with the wrong normal for that one beam segment. It'll be easier to see the example in the video than just the explanation. But since this is just one continuous mesh with no corners, we can select extras if we need to. Now, I should have checked the normal direction of my mesh before executing this command, because if the normal is pointing outward, I'm going to have the beams on the wrong side of the hull. Grab these meshes. I thought it's separated. No, that is just the hull. Okay, so export selected, and we will write this out as a polygon mesh file, a PLY file, and this goes into LTSB. It's an ASCII file, and you don't need any of the additional items checked for information in there. I'm going to also write out the decks very quickly. Now these could all be written out all at once in the same file, but then they would all come in the same module in Maestro. So we'll see that in just a second. In the meantime, I am going to grab the frames here, and yeah, I guess they were for the entire hull. And I'm going to export those, but this time we'll do the polyline on mesh, but restricted to a plane. And we'll select all the hull meshes. And we'll tell it I want to use a constant X value. So we'll pull in the hull. And I like to leave this transform nodal coordinates checked. And we're working in meters. So we're good there. Now, when we pull these things in, one thing I like to do, and for whatever reason, even though it doesn't indicate the nodes are turned on, they get turned on whenever you import a PLY file. So you can just toggle that on and off to get rid of them. I like to do this renumber FE tags. As we mentioned a while ago, in each module, you can have a node number 1 and a quad number 1, a tri number 1. So you can have multiple quad number 1s. There's just a different one in each module, but FE tags are unique. So even though you can have a different quad 1 in each module, you will only ever have one FE tag number 1. And I think this is no longer an issue, but it used to, when you pulled in a PLY file, sometimes it would set up a default FE tag number. And if you pulled in multiple PLY files, you could get duplicate FE tags. Now, renumbering FE tags is incredibly quick. It takes, maybe a second, even on a large model, but it can solve a bunch of problems. If you are checking for free edges, but you're pretty sure there's no free edge there, or you think something's off with it, the first thing to do is always renumber FE tags, because basically it reindexes the model. And sometimes if it just got a little bit out of sync, it can cause odd errors because it thinks things are connected that aren't. I like to do that just as a precaution between imports when I import PLY files. And you don't have to keep turning off the nodes between each one because they will get turned back on, so you can just do it at the end. Just cycle them once. So the other thing I want to do is import the MNF file, and that's the Maestro neutral file, and that can contain more than just the polygon geometry. That can contain, loads, and it's an entire model just in a neutral format that was created so that Maestro could pass information to other software packages. So we'll import the deck frames here and import the deck stiffeners. Now, I didn't check the normals on the hull, so this will be interesting to see if they were all in the right direction. Looks like they were. And the hull stiffeners. Now, by default, these are all only little 5-inch beams. Oh, no, they weren't. See, we can see we've got some frames on the outside of the hull. And this is what I was talking about where, and Actually, there's a frame that I missed that was overlapped with a bulkhead. I forgot to delete that curve, so it went ahead and exported it. Now, since I told it to use the normal from the hull, as it marched down, and I guess it went from the bottom to the top, that was the direction it was created. When it was looking to find the normal for this first beam segment, the hull mesh above and below the second deck were two separate meshes. And the one above the second deck was pointed in, the one below the second deck was pointed out. When it went to look at this beam segment and say, you find the corresponding node, I had given it both of these meshes as reference meshes, and apparently when it searched, it found the node from the lower hull mesh with its outward normal, and that's what it used to assign that beam segment. When it searched the next segment, it looked for this node, and that was only on this upper mesh, which was pointed inward. So it used that normal. But that's why you see some of these flip-flopped. And you can see this particular beam segment here must have been ordered from top to bottom, so that the upper node was the first node on this segment. So when it searched for which mesh to use, it found the point on this upper one, and it was pointed inward. So that's why you see that they're not all on that row. They're not all pointed in or out. So that's where you need to be careful of, if you have a beam segment that is on the corner of like a longitudinal and a transverse bulkhead, if you have them both listed as reference sections, you don't know which one it's going to find first. That's why when I do this, I typically like to do all the beams on my transverse bulkheads in one export, and I'll do all the beams on my longitudinal bulkheads in another export. That way, when I'm only selecting transverse bulkheads as my reference meshes, I don't have to worry about whether or not there is an intersecting one that it could find the wrong node. So I'll correct the normals on this before I send the model. You can use this model with all of the beams already exported to just get some practice exporting the traces. I did put beams on the transom, okay. And I put some intercostals on here, these horizontals on the side and everything. So it should be a reasonably complete model. That should pretty much cover it. That'll get you up through importing the geometry into Maestro.